Okie dokie. So the question is, consider the function f of x equals log to the base e of x plus 3 in brackets all squared. And the question that you said you had trouble with was determine the domain of f. So can you tell me for what values can you take a log?
It has to be positive?
Exactly, has to be a positive number. Now let's say that x was 6. Is that okay? Is that in the domain?
Yeah.
It is. What if
Yeah.
x was negative 6?
It wouldn't be because it would equal -3.
No, put negative 6 in place of x. What's negative 6 plus 3?
-3.
Negative 3. What's negative 3 squared?
Oh my god. It's like timesing a negative. Is it 9?
Is positive 9. So in other words, negative 6 is in the domain because negative 6 plus 3 is negative 3, but negative 3 squared is 9. So that's just the log of 9,
Okay.
which is fine. Okay,
Yeah.
so negative numbers are okay, positive numbers are okay. Oh, in fact, there's only one negative number that's not okay, and that is negative 3. Because if x is negative 3, what's negative 3 plus 3?
0.
0, and 0 squared is 0, and you can't have the log of 0. So that's why that basically says you can have any real number except the set negative 3. So except negative 3. That's the mathematical short way of writing. Any real number is fine except that one.
Okay.
And if you had two numbers that weren't acceptable, like negative 3 and negative 2, it'd be negative 3, comma, negative 2, etc. Okay, happy with that?
Yep.
Okay, no, make sure you ask questions if you're not sure, because this is a good opportunity to do so. But let's have a look at question B, because this is something I actually hadn't done before. So when I saw the question, I said, I'm not sure why this is the case. So can log of that be written as 2 times the log of that? So when I first saw this question, I thought it can be, because you just move that 2 down to the front of the log. That's one of your log laws, and you get this. But when I checked the answer in the back of the textbook, it said they're actually not the same function. So the formula is the same, but the domains are different. So if the domains change, when you do an alphabetical, you do a log law in this case, then you can't say that the two functions are the same. So you therefore, if you're finding the log of that, you can't do that first unless you also put in what the change of the domain is. So why is this function have a different domain to that one?
Because in the second one, you're not squaring it.
Exactly. So give me an example of a number that is in the domain for the first function, but not in the domain for the second function.
Would it be like -6 like we used before?
Exactly. Yep, exactly. -6 is fine for this one, but log of -6 plus 3 is -3. The log of -3 doesn't exist. So that one does have an answer, and that one doesn't. So the best way to explain it, say that was on an exam question, the best way to explain it would be to give an example. To say if x was -3, that's in the domain of the first function, because it's the log of a positive number, but it's not in the domain of the second function, because you can't have the log of a negative, and therefore I'm not allowed to write that as that, because the domains are different.
Yeah, okay.
Okay, happy with that? So most functions that doesn't happen, but because logs are only, you can only take the log of a positive number, that's why it's coming up in this chapter.
Okay.
Okay, did you have a go at question C? You want to have a look at that one right now?
Oh yeah, I didn't get to that one. I thought I would just save that.
Okay, do you want to try it on your own later, or want to have a look at a solution right now?
I think I'll just try it on my own later because I've gotten pretty good with the, like, getting the derivative and stuff.
Yeah, pretty much it's just a chain rule function, so it's no different to the ones you've done previously.
Mm-hmm.
And I did send out to you and all the other students all the work solutions. So if you do get stuck on it, you should have it in the email I sent out to all the students yesterday.
Yeah.
Okay, so that's 7B done. Sorry, 7A done. Let's move on to the next one. Okay, your question on number 9, differentiate that. Is that the one, 9B?
Yeah.
Okay, so what I did with this one, the way I decided to do it, I said, well, basically, again, it's going to be a chain rule question.
Mm-hmm.
So in general, I've got to first find the derivative of that, and then multiply it by the derivative of log of that.
Okay.
So what I decided to do, I said, well, finding the derivative of that, I can't just do it in one step. So what I did first is I said, I'm just going to call that expression G, just to give it a name. Then I decided to use, because it's a quotient, a fraction, I decided to use the quotient rule on that.
Okay.
So I just did v u dash minus uv dash divided by v squared. So that gave me that just there using the quotient rule. And when I simplified the numerator, I got that.
And did you simplify, when you simplified that one, was it just because the x's canceled each other out in the numerator?
Yeah, x minus x is 0, so they disappear. -1 subtract, -1 subtract 2 is -3. So it's that minus that.
Okay.
Okay.
And would there also be, for that one, would there also be another x in there? Because I got x take 1 all times x subtract x plus 2 all times x. So I thought they would just cancel each other out as well.
Okay, let's do the quotient rule on this one just here. So let me get my pen. Okay, and I'll make it red just because I can. Okay, that's U, and that's V. And I'm going to make it a little bit less thick. Okay, so in the numerator we have V, which is that. Can you see my pen moving back and forth?
Yeah, I can.
Yeah, okay, good. So it's V times derivative of that. What's the derivative of x plus 2?
Oh, it's nothing because you can't.
Well, it's 1. It is something.
Oh, yeah, I'm sorry.
Yeah. So basically, V times derivative of that is just V times 1. So that's just that. That's just V.
Okay.
That's V times 1. That gives me x minus 1. I don't have to have the brackets, but it doesn't hurt to put them in.
Yeah.
Okay, minus, and the second one is, see, it's V times U dash plus U, x minus, U, x minus x plus 2, I should come down here, U times derivative of that. Okay. So x plus 2 times 1.
Okay, yeah.
I have to have the brackets there. I'm subtracting all of that.
Okay.
So if I didn't write the brackets, I just had x plus 2, I'd end up with a wrong answer. Okay, and then to simplify, x take away x is 0. -1 take away 2 is -3. Okay, so that was just so I can get the derivative of the inside function. Okay, now I can apply the chain rule. So there's the original question on top. So to find the derivative, I'm going to pull my monitor a bit closer, excuse for a sec. To find the derivative of this thing, derivative of the inside function, and that's what I did over here on the left. So I just said the derivative of that is that. And then times the derivative of the natural log of something. Now, what's the formula? What's the derivative of natural log?
Was it the 1 over x thing?
Exactly. Okay, so I'm going to come up here and just write y equals natural log of, say, a over b. Okay, so the derivative of that is just 1 over a over b. You happy with that?
Yeah.
Whatever. Okay. And the thing is that now gives you what's called a complex or compound fraction. You got a fraction inside of a fraction. And to simplify that, what you can do is you can say, instead of dividing by a over b, instead of dividing by a fraction, you multiply by the reciprocal.
Oh, okay.
Okay, and that makes it into b over a.
Yeah, that makes sense.
So whenever you're dividing by a fraction, you can just multiply by the reciprocal. So that's what I did here. I said, this is really 1 over all of that. So I could just basically use this little rule just here and just flip it over. That's the reciprocal. So that's why it flipped over.
Okay, thanks.
Yeah, so that would, again, I'd say take a screenshot of this, because that's a useful piece of algebra for logarithms. Because of this log law, often you have to flip your fraction.
Yeah. Okay. Yeah, I got a screenshot of that one.
Yeah, again, most students forget it until they have to start using it again. But like I said, because of the log, the derivative of log is 1 over something. If what you're finding the derivative of is a fraction, you're going to end up with one of these things, compound fraction. So then you just say, okay, I can just flip it over, and it's no longer a fraction. It's just b over a. And then, of course, to finish it off, you got a common factor, because you got -3 times x minus 1, and you got x minus 1 times x minus 1. So you can cross out the common factors, and it just leaves -3 on top, and x minus 1 times x plus 2 on the bottom.
Okay, yeah.
Okie doke, happy with that?
Yep.
Okie dokie, let's move on to the third question. Oh, first off, before we do the third question, this wasn't from the textbook, so you probably didn't see this, but the log function that you've been using only works for natural logs, logs to the base e. So how do you find the derivative of a function that's a different base to e? For example, log to the base 2, log to the base 10, log to the base 5, log to the base anything.
Yeah.
And what you have to do for that is use your change of base rule. Okay, so basically, you can only, at the moment, you only know how to find the derivative of log to the base e. So if you don't have log to the base e,
you got to change it to log to the base
you
e.
basically say, I can rewrite log to the base a of x is natural log, which is log to the base e of x over log to the base e of a. Now you can use your rule for derivatives of logs, because you now have the natural log. Okay, and that's just going to become, okay, so first off, this natural log of a is just a number. Happy with that? Because it's whatever a is, so I just put that out the front as a number. That's like a coefficient. I just rewrote the equation, putting that out as a coefficient of natural log of x.
Okay, yeah.
Okay, so rather than the fraction, I said it's just something like a number times natural log of x. And of course, that just means I still have that number there, and the derivative of natural log of x is 1 over x. And then the last thing you do is just say, well, that's 1 times 1 is 1, and natural log of a times x is natural log of a times x.
Okay, yep, that makes sense.
Yep, and by the way, these brackets are essential because it's only a that you take in the log of, not ax. So if I'd written that this way, natural log of ax, like that, that implies that, which is not the same as that. So you got to be very careful with your brackets, so that you're making it really clear what you're taking the natural log of. So in this case, it's important that I just have the natural log of a in brackets, that number times x. Okay, so I'd suggest you write down that little rule. That's basically what I just proved just there. So if you've got the log to any base other than e, that's how you can find its derivative.
Okay, yeah, got that down.
Okay, right. So that's going to be needed for the next question, the one that you asked about. Okay, so in question 13, there actually were 4 parts to it. So I did the first 2 parts, and then using f of x, and then you can have a go later on parts c and d using the g of x.
Okay.
Okay, so given that this is log to the base 2, that means before I can use my log law, I have to change that to log to the base e, or the natural log. So can you tell me, this is a bit tricky because you only just wrote the rule down, can you tell me how can I rewrite that so it's log to the base e? Using that rule down there.
Would I have to change the base first?
You do, like, here's the first half of it. Right? You're changing the base from base 2 to base e.
Okay, so would it be a natural logarithm like that one at the top, and then the denominator would be the natural log of 2?
Ta-da, well done, there you go. Okay, so that's whenever your base is not e, that's the first thing you have to do, is rewrite the log expression to base e. Now, once again, that natural log of 2 is just a number. Oh, and that's write the rule for f of x. Okay, that's all we had to do for that one. That's the answer. It didn't ask us yet to find the derivative. It just said rewrite it using natural logarithms. So stop there. And you could, of course, also done what I did before. You could have said, well, natural log of 2 is just a number. So I'm going to just put that out the front. And then I have natural log of 3x plus 2. So you could have written it like that if you wanted to.
Okay.
That one there is the same as that one there, just written slightly differently. Happy with that?
Yep.
Okay, so question B is now you're going to go ahead and find the derivative of that. So this here, in fact, I might have done that first, I think. Yeah, that's what I did there. My first step, I'll put the 1 over natural log of 2 out the front. Okay, and that's just a number now. So you just keep copying that down. You don't find its derivative, just copy it and use your chain rule on this. So what's the derivative of the inside function?
3.
What was that, sorry?
3.
3, yep. So it's going to be that times 3. And what's the derivative of the natural log of something?
1 over x would be 1 over 3x plus 2.
Exactly. So that's exactly what we have here. Just copy that down. Derivative of the inside function's there. Derivative of natural log is 1 over that. And now we just have to go ahead and simplify that. So 1 times 3 times 1 gives us a 3 on top. That's just a number, so it's just that times that.
Okay.
Okay, and you could put brackets. You could have put brackets around to make it totally clear. In fact, I probably should have done that because I don't know whether this is the natural log of all of that or the natural log of that. So probably to be more clear, I should have had brackets like so to show that that's a number and only taking the natural log of this and not of the entire expression. So that's probably a better answer. And that's it for question 13.